Molarity is the number of moles of solute in 1 liter of a solution. So mole fraction of B is equal to number of moles of B divided by total number of moles of solution. Limits the amount of product in the reaction and therefore it is called as limiting reagent. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence. So we shall continue the chapter, some basic concepts of chemistry. And in the previous session, we have learnt about mole concept, percentage composition and stoichiometric calculation. And in this session, we shall learn about limiting reagent and also concentration of solution. So let's get started with the limiting reagent. What is limiting reagent? It is the reactant in which it gets consumed first or limits the amount of product in the reaction and therefore it is called as limiting reagent. We shall understand this concept by using an example, that is nitrogen when it reacts with hydrogen gives ammonia, and with the balanced equation, that is 1 mole of nitrogen reacts with 3 moles of hydrogen gives 2 moles of ammonia. So this balanced equation is expressed in terms of mole. So that is 1 mole of nitrogen, 3 moles of hydrogen and it gives 2 moles of ammonia. They are in the correct stoichiometric ratio because this is a balanced equation. So the correct stoichiometric ratio is 1:3. So there is no limiting reagent. Suppose for the same reaction, if you are given 2 moles of hydrogen, what would be the stoichiometric ratio? Now actual stoichiometric ratio is 1:3. So you are given only 2 moles of hydrogen. So from the equation, you need 3 moles of hydrogen, but this 2 moles of hydrogen is not enough for the reaction to take place or to form a product. So that is why the hydrogen is called as limiting reagent. It is going to limit the formation of the product and the formation of the reaction. So next we shall learn about concentration of solution. Majority of reactions in the labs are carried out in solution form. So it is important to understand how much of amount of substance is present in a solution. So therefore, the concentration of a solution or the amount of substance present in its given volume can be expressed in these 4 ways, that is mass percent or weight percent, which is expressed by W by W percent, then mole fraction and molarity and also molality. So we shall understand one by one what is the concentration of solution using these 4 ways. So the concentration of a solution in terms of mass percent or weight percent can be expressed by the formula mass percent equals mass of solute by mass of solution multiplied by 100. Now we shall understand with an example. So we'll try to solve this question. A solution is prepared by adding 2 grams of substance A to 18 grams of water. So 2 grams of substance A is added to 18 grams of water. Now calculate the mass percent of the solute A. How to calculate? Using this formula, that is mass percent is equal to, what is mass of solute? That is 2 grams. Here the solute is substance A and mass of solution is 2 grams plus 18 grams, that is to be multiplied by 100. Now therefore 2 grams divided by 2 plus 18 is 20 multiplied by 100. It gives 10%. So the mass percent of the solute is 10% that is present in the given solution. The other way of expressing the concentration of solution is mole fraction. Mole fraction is the ratio of number of moles of a particular component to the total number of moles of the solution. Suppose A is a component that dissolves in B, then number of moles of A is given by Na and number of moles of B is given by NB. Okay. Now for the particular component A, how to calculate the mole fraction? That is, mole fraction of A is equal to number of moles of A divided by total number of moles of solution. And there is one more component, that is B. So mole fraction of B is equal to number of moles of B divided by total number of moles of solution. So therefore, mole fraction of A is equal to number of moles of A divided by total number of moles of solution. So it is expressed as mole fraction of A equals, now number of moles of A is represented by Na divided by total mass of number of moles of solution, both A and B. Similarly, the other component, that is mole fraction of B, is equal to number of moles of B divided by total number of moles of solution, that is expressed in mole fraction of B is equal to NB, that is the number of moles of B divided by total number of moles of solution. Now we shall try to solve this question using mole fraction. Calculate the mole fraction of ethanol in a solution containing 46 grams of ethanol and 180 grams of water. How to calculate the mole fraction of a particular component, that is ethanol. So first we'll write the given data. So mass of ethanol is given 46 grams and mass of water is 180 grams. Using the formula of a mole fraction, so we have to find mole fraction of only one element, that is ethanol. Mole fraction of ethanol is equal to number of moles of ethanol divided by total number of moles of solution. In the formula it is given number of moles, but in the data it is given mass of ethanol and a mass of water. Now how to convert from mass to moles? So that is, for N, number of mole of ethanol is given by mass of that substance divided by molecular mass of the ethanol. So mass is given, that is 46 grams divided by molecular mass of ethanol is again 46 grams. So it gives 1 mole. So similarly, number of moles of water, that is H2O, it is given 180 grams divided by 1 mole of water molecule consists of 18 grams of molar mass, it gives 10 mole. Now substitute this answer to this equation. Therefore, mole fraction of ethanol is equal to, so number of moles of ethanol that we get is 1 mole divided by, it is total number of moles of solution. So you have to add both the moles, 1 plus 10. So it gives 1 divided by 11. Upon dividing, we get 0.090 moles. So that is how you're supposed to calculate the mole fraction of an ethanol in this given solution. So we shall see the another way of expressing the concentration of solution, that is molarity. Molarity is the number of moles of solute in 1 liter of a solution. The molarity is expressed by the symbol M, and using the formula, that is molarity is equal to number of moles of solute divided by volume of solution in liter, we can find what is the molarity of the solution. For example, 1 molar of NaOH solution represents 1 mole of sodium hydroxide is present in 1 liter of a solution. Okay. Suppose 0.2 molar of NaOH solution is given, that is 0.2 mole of NaOH is present in 1 liter of a solution. So we shall try to solve this question, that is calculate the molarity of sodium hydroxide in solution which is prepared by dissolving 4 gram of sodium hydroxide in enough of water to form 250 ml of the solution. So there is like 4 grams of sodium hydroxide is added to the water which is unknown to prepare 250 ml of solution. So what is given? Mass of sodium hydroxide that is dissolved in the water is given 4 gram and volume of the solution is given 250 ml of the solution. Now the first thing to find is number of moles. How to find the number of moles? That is number of moles of sodium hydroxide is equal to mass that is present in the solution divided by the molar mass of sodium hydroxide. So molar mass of sodium hydroxide is 40 grams. So that is 0.1 mole. Now 250 ml of solution is given, that has to be converted to liter. If 1 liter is equal to 1000 ml, what is 250 ml of the solution? So it is 0.250 liter. Substitute these two values in the equation, that is molarity expressed by M is equal to number of moles of solute is 0.1 divided by volume of the solution in liter is 0.250. Therefore, you get 0.4 mole per liter. So this is in the unit form. If it has to be expressed in the molarity form, that is 0.4 molar of sodium hydroxide is present in 1 liter of a solution. So that is the meaning of molarity. So we shall understand now what is molality. Molality is defined as the number of moles of solute present in 1 kg of a solvent. This is denoted by M. Now the formula to calculate the molality is number of moles of solute divided by mass of solvent in kg. This is solvent in kg. So now we shall try to solve this question based on molality. So what is the question? The density of 3 molar solution of sodium chloride is 1.25 grams per milliliter. Calculate the molality of the solution. So first we shall write the given data, that is 3 molar of NaCl means it is 3 mole per liter. 3 mole of sodium chloride is dissolved in 1 liter of solution and then density is given, that is 1.25 gram per milliliter. And also you should be able to find mass of sodium chloride, that is 58.5 grams. Since 3 mole of sodium chloride is dissolved in 1 liter of solution, so that is why it is to be multiplied with 3. So 3 into 58.5 gives 175.5 grams. Now we have to find the mass of the solution using density. We know that density is given by mass by volume. And using this equation, on simplifying, mass is equal to density into volume. What is density? It is 1.25 and the volume is 1 liter is equal to 1000 milliliter. So 1000 milliliter. Therefore, it is 1250, that is 1250 grams. This is the mass of solution. So this is mass of solution, this is mass of solute. Now you have to find mass of solvent. How to find? So mass of solution is equal to mass of solute plus mass of solvent. Okay, so mass of solution is given 1250. Mass of solute we have found, that is 175.5 plus solvent is unknown. On shifting it on the left side, (1250) minus 175.5 grams. On subtracting, we get 1074.5 grams. So this is expressed in grams. So if it is converted to kg, it is 1.074 kg. Now we know that mass of solute is 175.5 gram, mass of solvent is 1.074 kg, and mass of solution is 1250 grams. Now, using this data, we have to calculate the molality of a solution. Now, what is the formula to calculate the molality of the solution? So, the formula to calculate the molality of the solution is, so first we'll write the data, that is mass of solvent is 1.074 kg. Now, we know that molality is equal to number of moles of solute divided by mass of solvent in kg. So, number of moles, how do you find out? It's understood 3 molar of sodium chloride is nothing but 3 moles of sodium chloride. So, the number of moles of sodium chloride is 3 divided by mass of solvent is 1.074 kg. Upon dividing, we get 2.79 mole per kg. So, this is molality of sodium chloride in a given solution. One more thing about molality is, the solution of higher concentration is known as stock solution, and you can prepare a diluted solution from a higher concentrated solution. So, the molality of the solution will not change according to the temperature, it remains as such. So, this is about some basic concepts of chemistry. So, in the next class, we'll meet with a new chapter. Until then, thank you.